Okay, so today is the last day of review for graphing. This is graphing number 5 is what you're going to be seeing. And you really haven't done that much graphing yet. And that's mostly because the test is not super hard at all. Oh, sorry, my mic keeps going in and out. It all depends on how you think, how hard you think this is, for instance. Well, try it. Tell me what you think the answer. Make me a little sketch. And you really, this is not a sketching test. This is a graphing test. So you sketch it to kind of get an idea of general. And you definitely do it in pencil. I mean, you're not going to be able to, on the test anyway, erase your pen. Oh, start here is like this. And have to do if I'm going to start on the inside. I'm going to move it 2 to the right. You see how that's very subtle? It's not a big change in the graph just because of the way that's shaped. If I moved up or down, it's much more dramatic, but 2 to the left isn't a big change. All right. That's to the right. Then the negative here, the negative flip like this, and the most common mistake is to go like this and flip it over the axis. So it needs to be keeps on going in and out. It's driving me nuts. What must be wrong with the mic? Anyway, I'm gonna do my best today, and I'll try to get it. All right. That I think it is, and I also need to have my asymptote in there somewhere. So I'm gonna go like this. The x. No, that's not x equals. That's equals 0 is my asymptote. And now I'm going to check some. All right, so if I wanted to be sure I was right, and on the test, of course, you're going to want to be sure you're right, you need to plug in some points. So what are some good points to try? You want to make this top part here 0, because anything to the 0 power equals 1, and that'll make it really slick. So I'll put in a 2. That way, this will turn into a 2 minus 2, which makes it a 1 up there. 0, sorry. And anything to the 0 power is 1. So all of this is 1. But the negative does come in at the last and does the last thing to it. So it's negative 1. So 2 comma negative 1. If I go over 2 and down 1, looks like I moved down too much. That's a little better. See, I've already made an adjustment to my graph based on the point that I found. Do you have to graph like unlimited points? No. You only need to graph a couple points. If you have a couple points graphed and the asymptote in the right spot, you'll be fine. Let's just do one more point. What if, hold on, what if this thing on top here was equal to 1? Then anything to the 1 power, no, e to the 1 power would be e. So I'm going to put in a, let's see, 3. If I put in a 3, 3 minus 2 would be 1, e to the 1. Now I got negative e to the 1, which would be negative e. So it's negative e. So that's negative 2.718. So 3 comma negative 2.718. So that's about right. I'd be fine. If you want to write 2.718, I'd be fine with that too. But I know what e is. So, all right, there we go. I got a couple points on there. Now I know my graph looks good. I've had many times where I've thought I did my flip right, and then I actually do the math on it, and like the dots are going here, and I'm like, oh my gosh, I'm in a completely wrong spot. So make sure by checking the XY chart. All right, question. Somebody have a question? Yes. Yes, you will get graphing paper to do the test questions upon. All right, so let's try this one. Log base, let's say 3 of x minus 7. Try sketching that quick. It should be an easy one. If you know where the parent log is, it should be a snap. Yep, this is just a sketch. Okay, so generally, would you agree that log graphs start looking like this? I keep saying it looks kind of like a tree because it's got roots in the ground here, and you know, like, let's say it's a tree like this, been blown over in the wind. Okay, it's a red pine tree. Anyway, it's a log graph. It's just to keep you from getting confused about the exponentials, which kind of go up like this, which are completely different. All right, they're related. Now I'm going to take that tree and move it, log I mean, and move it 7 to the right. There. Do you agree? Okay, now I'm going to throw in one more twist. So it had a negative there. Now actually make it a graph. So in other words, graph this. Do the things you'd need to do to pass the question on the test. In other words, just a sketch is not good enough now. Yes, sir. Do the parentheses matter? Yes, they do, because it's telling me that I moved to right of 7. If there were no parentheses there, then that would mean that it's an up or a down 7. So if this looked like this, negative log base 3 of x minus 7, then you would know, oh, my whole log needs to move down 7. Okay, I'll look back at this. That was up in the exponent here. That was all in the exponent. If this had been e to the x minus 2 like that, that would have been down 2. But since it was up here, that meant that it was with the x, and that meant that it was a right-left thing, and that thing was to the right. Okay? All right, back to this one. Since these are, neither one of these is an exponent, and therefore if I write it like this with no parentheses, that would mean move it down 7. The way I wrote it has parentheses, so it meant right 7. Okay, so now how do you make this into a actual answer that would be worthy of getting full credit on a test? First thing you have to have is the asymptote. How many of you remember to put in the asymptote? Yeah, see, a lot of people would have lost the point right there. Asymptote and 2 points. Asymptote goes like this. And the asymptote's at x equals 7. Is it just a coincidence that 7 would make that parentheses 0? Nope. Whatever makes the parentheses part 0, that's the asymptote. Okay, so since x equals 7 makes that 0, I know x equals 7 is the asymptote. Okay. Next thing is I had to do this negative in front, and that's the up-down flip. That's going to make it kind of look like that. Now, how tight is the turn? That's kind of what my XY chart's for. So now I've got a decent sketch. Now I got to make sure it's right. So now I'm going to make my XY chart. X, Y. And what are some points that you know would be good ones to put in? 8. All right, I'll put in x is 8. Why is that good? Because that makes this whole thing 1. Anytime the argument part is 1, I would have y equals negative log base 3 of 1. And there's a 1 right there. The answer is 0. And negative 0 is still 0. So, 0. So 8 comma 0. Hey, I'm right on the right spot there. It's a good sign. Just need one more point. What's another good thing to put in here? Make this turn into a 10. Oh, I see what you mean. You want to put a 10 into it. Okay. If I put a 10 into it, that's going to make it equal 3. Why is that good? Because then I have log base 3 of 3. And then this part is 1, and the negative in front of it makes it negative 1. So it'd be 10, comma negative 1. Then I go 10, comma negative 1, and that's about right. Yay. Maybe it's a little too steep, because that was 8, so maybe 10 should be like more over here. So maybe it should be more like there. So all I'm saying is maybe my graph wasn't quite steep enough. So I could erase this, and on the test this is all what I do. Say, okay, now I'm going to go through those 2 points. I got 2 points, I got the asymptote labeled, then I'm good. Yes? You mean the x and y axis? The x and y axis will be there with some grid. It'll kind of look like this. It'll be like, yeah. Their graph, somebody else asked it in a different way, but yes, there will be graph paper kind of provided. Technically it's not graph paper, it's just a little piece of graph paper within your document. All right, let's do another one. ln, the hardest of them all. Why? Because You got to find these points, and some of them have e in them. And so I'm going to say ln negative 2x minus 1. Give that one a shot. And I just wrote it wrong. Sorry. Negative 2x minus 1. I made it look like it was an exponent, but it was not. This is important. If I were forced to put in parentheses, the parentheses I would put in would be like this. Make it clear whether that 1 means to the right 1 or whether it means down 1. Get the feeling you're not completely with me. Okay, I'll graph you an ln and start with here. All right. So here's the way they generally look. ln is just a log graph again. It's just not as tight as last time. Log base 10 is really sharp turn. Log base e is just not as sharp a turn. They always go through the point 1 comma 0, that point right there, to start with anyway. And they always have an asymptote like this. It's just like the other log, it's just about how steep or how tight the turn is. And this has a base e. ln is the same as log base e of negative 2x minus 1. The asymptote is whatever makes this equal 0. What would make that equal 0 if I put in x equals 0? So x equals 0 is the asymptote. And it is right there, and it's going to stay right there. But I do have to do some stuff to this thing. What's that 2 mean? The 2. The 2 is a shrink. Which way? Horizontal shrink. Alright? It's got to get a little bit narrower, like squished down to half as wide as it was. So this point was this wide before. Now it's got to be like that wide. So I'm going to undo that. Still has to go through, wait, half as wide, so it has to go through over here. So, and alright, there's my half as wide. What was this negative here going to do? Left, right? Yep, that is a left-right kind of thing because it goes across this y-axis. Okay, so then it's going to be like this. And then the last thing is that, which is what? Down 1. So my green one is my final graph then, where the blue one, sort of like grab the blue one and drag it down. Okay, now I'm going to use my surgical eraser here and carefully erase all these in-between ones that I did. Not there anymore. Down. Just the green one. Okay, I got a little blue left underneath there. It's hard to get at. Okay, good enough. So then, if I think that's my answer, I should label my asymptote x equals 0. I never moved the asymptote in this case. Then, I should double check it with some points. X, Y. What are some points that would work? Serious? I will check. Negative 1/2 e has been a proposal to put in. If I put in, have I done it right? Negative 1/2 e, is that what you want? Okay. Then this times this would equal 1, and you would just turn it into an e here. That's pretty cool. Because then ln e means log base e of e, which makes a 1. And then you subtract 1 and you get 0. So the grand total would be, if I put in negative 1/2 e, I'd get 0. Now what the heck is negative 1/2 e? Negative, well, half of e is 2.718, so half of 2.718 was about 1.4-ish, and then I am about to make that negative, so about negative 1.4. So 0 comma negative 1.4 means it should be touching. Now why should it be touching? Oh, thank you. Thank you. The x is negative 1 point. Phew. That makes much more sense. It is touching right there. Whew. Okay, we normally don't have such a weird x, and forgive me for not being able to handle that well, but that was a tough one. It worked. Okay, now I'm going to try another one. And this is the hardest kind because there's not too many things you can do that work nice with a base of e. But if this part right here were made into a 1, then there. The flat part I circled in black there, that part there was made into a 1. You get how it would be ln of 1. And anytime there's a 1 right there, then the answer to this part becomes 0. And 0, so that's a good thing. So how can I make this part right there equal 1? Nope. This part right here, negative 1/2. Negative 2 times negative 1/2 would make it equal 1. And then I'd have ln of 1, and then I got to subtract 1 from that. So negative 1/2 is a good idea. And then I would get ln 1, which is 0, minus 1, which is negative 1. Negative 1/2, comma negative 1. If I go to negative 1/2, which is less than this, where this dot is, that actually works out really well. It's about there. Yeah, I got 2 points. I got an asymptote line. And how steep that is probably anybody's call, but if you've got 2 points and you got the asymptote in the right spot, then generally, I don't, unless you do something crazy with this, woo, then I'm going to mark it wrong, but it's right. Okay, that's the basics. Now, let's just give you a bunch of time then to work on some practice problems in your homework. Now, lunch is in 5 minutes, a little too early for that. Here is your worksheet. I will start it with you. Thank you, I will. Okay, everybody's got a worksheet. Number 1, A. It says, roughly sketch and label the following. That means you don't need to be really paranoid about where these are and make an XY chart. It says that right in the directions. Okay, so y equals 2 to the x. Do you generally know where that puppy is? All right. And it always goes through here. So, and then how steep? I really don't care. I said I don't mind if you don't make an XY chart. So basically, there you go. There's A, and you label it with an A. B is a little trickier. It's like the first one, except we got to move it where? Right 5, and then what? Flip it. So if you can picture that in your mind, that this whole thing has to move right 5 and then be flipped. Here's the right 5 part. Grabbing it, go to right 5, and then you have to flip it. I'll let you flip it, and flip it good. Okay, on to number 2. This is just what order to do stuff in. We have practiced that so many times, but it is important. Like, look at number 3, or 2A. Number 2A, I would get a free answer here, and stay with me. It says 2 to the, or 2, and then a 3, and then a power of negative x plus 4. And then they want to know what order to do it in. I would recommend you always start on the inside. If nothing else, the key that I made and posted for you has them all starting from the inside. So, number 1, on the inside, you do not do that first. You do that first. You have to do the left 4 first. Why? Because the order of operations is backwards when you're on the inside. Okay, this one is normally first, but in this case, it's second. Because it's on the inside. And that's a, which way flip? Left, right, which goes over right. Reflect over right. Then the last thing we do is the outside, which would be 2 times taller, vertical, stretch, factor 2. Okay, get the idea on that one? That's how you do it on the rest of them. Then flip it to problem 5. I would start the problem by generally sketching it, but I do it lightly and in pencil, and generally getting an idea of where I think it should be. And then I would go check it with my XY chart. -3 to the x plus 4. All right, so my thought is, first of all, that the 3 to the x would generally look like this. Then that negative, oh wait, I can do it in either order. I'll do it start on the inside like I usually do. 4 to the left. I'm going to grab this thing, move 4 to the left. Then the negative is going to make it flip, so generally I think it's going to go kind of like that. Remember, I said this is how you should start, but it is not how you should finish. If you left it this way, I would definitely mark it wrong. Probably with emphasis, with enthusiasm. Okay, what I would want is that soon you'd have an asymptote right here, and you'd label that. Quiet, please. All right, just take longer for me to finish. And then I need an XY chart. And how many points do I need on that XY chart? At least 2. At least 2. But now it is lunchtime. Okay, so to finish this problem off after lunch here, what we had to do now is check some points. So I would say making right there into a, okay, -2 sounds good. If I put in -2 right there, then I'd have a 2 and -3 squared. A lot of people will screw that up and they will say that it's +9. You have to do the squaring first and then you apply the negative. The answer to that is -9. If you don't believe me, try it with a calculator and don't put parentheses around it. -3 squared. It'll do the 3 squared first and then it'll make it negative and it'll be -9. Okay, so -2. Oh, wait a minute. Something's way off. I must not have done some kind of a shift correctly. I was supposed to shift it 4 to the left. Did I ever shift it 4 to the left? Well, -2, -9 implies I should have shifted much farther to the left. So, all the more reason to check. -2, -9 goes down here, let's say. And now I'm going to try another point like -3. If I put in -3, I'll have a +1. -3 to the 1 power. That's 3 to the 1 and then make it negative. So it'll be -3. -3, -3. That should be a little higher, like maybe here. So, yeah, that's another way to say it. Yep, should have been more like that. Now I've got 2 points. I've got the output, and less likely to get it marked wrong by the teacher because I've got points to prove that I'm in the right spot and an asymptote in the right place. Yay. Okay. So, I'm going to just give you a bunch of time. Please use it wisely. And then if you want to check yourself to see if you're doing it right, the answers are already posted. But therefore, since you could just check answers anyway, it's fine with me if you use a calculator to check them. But obviously the test won't allow calculators, so don't just use that for your homework. That's really stupid. You can just copy the answers if you're going to do that. Learn it and use a calculator to trick it. Yes. I am going to just say this one more time. I strongly recommend an XY chart. Do you have to have it? No. If you don't have it, and you don't have 2, not promising to give you the credit because we're close. Like my answer, it really wasn't very good. Good point. Exponentials. Either way, I want you to have 2 points in the asymptote. 2 points in the asymptote. You have to have a chart for those 2 points. If your graph doesn't go through at least 2 points that are correct, then your graph isn't in the right spot. So like if I thought this was kind of close and I said, that's not right. It only has 1 spot in common with, you have to have at least 2 points in common with the right graph. So the blue one's right. The green is kind of close, but not close enough. This isn't a sketching test, graphing test. Yes, you need some points. 2 points in the asymptote, and then you're good. So I guess mark yours wrong if there was no XY chart. No, but if you didn't have 2 points that were in common with the correct graph, then I would not give you the credit.